All right, in this video for lesson 3.8, we're going to talk about why some elements are radioactive, specifically why some isotopes are radioactive, right? So just to give you a general idea of what radiation is, this video summarizes how we detect certain types of radiation. So this machine is called a Geiger counter. It makes kind of like a clicking noise every time it's detecting radiation. So this individual placed an object that's releasing something called beta radiation, one type of radiation, and he's going to talk about how you can block it. But mainly what I want you to hear is that clicking noise that's given off when we're measuring radiation.
And stick in here, and you can see that the
So you can
paper
hear the clicking noise still.
doesn't do anything really to block that beta radiation. But something like a sheet of plexiglass, if I stick that in between there, that'll block it down and send it right back down.
So when it's blocking the radiation or the particles being emitted from this object, you don't hear that clicking sound as much because this part of the machine is the thing that detects the radiation, right? And he's placed this plexiglass right in front. So it's blocking the radiation that's coming off of this object. So we can't see it, but we can detect it with something called a Geiger counter. So you might wonder what makes certain things radioactive or emit radiation, right? We know that radiation is just energy or particles being emitted when a radioactive isotope decays, right? And radioactive isotopes are elements that produce radiation or energy due to their instability. So let's talk about this definition first. Right? So if I look at lithium, when lithium is stable, it has 3 protons and 4 neutrons. But if I add more neutrons, it starts to become unstable. Or if I take away more, right, it also becomes unstable. So the ratio of protons and neutrons helps us define whether an isotope is stable or unstable, right? And that's summarized in this graph. So notice on the x-axis right here, going left to right, this is the number of protons I have. And on the y-axis is the number of neutrons that I have. This line is a 1-to-1 ratio of neutrons to protons. So if I have 14 protons, I have 14 neutrons. So when you first start out, you'll notice that if the number of protons and neutrons are the same, it's fairly stable. But as the elements get larger, meaning that the more number of protons you have, you're going to need more neutrons in order to keep it stable. If you have too little, as shown by these orange and yellow and red boxes, right, you're going to end up with an unstable or a radioactive isotope. If you have too many neutrons, as shown by the blue boxes, right, it will also end up being a radioactive isotope or unstable. And when they're radioactive or unstable, they tend to shoot off these energy particles that we call radiation. So there's mainly 3 types that we talk about here. So when an element is unstable, we call that the parent element. It's going to be kind of shaky like this, and then something's going to shoot off out of it, right? And there are 3 common particles that can shoot off. One is known as the alpha particle, another type is a beta particle, and the third we call a gamma ray, right? So for an alpha particle, this type of radiation tends to be fairly weak. We only need to worry about it if we accidentally swallow it or something like that, because mainly we can block it off with a sheet of paper or our own skin, right? Beta particle on the other hand, a little bit trickier to block, right? We would have to block it with something like aluminum foil. This could kind of go through our skin and maybe cause some damage, but not that much. The most dangerous is symbolized by this. This represents a gamma particle, right? Very similar to the microwave or when you go to the dentist and get an x-ray, right? They give you x-rays, which are sort of similar to gamma particles, right? And this penetrates through most objects, which is why they're useful for x-rays, so we can see inside your body. And this is also why at the dentist, you wear this like heavy cloak thing, right? It feels super heavy on you, right? And that's because that thing is made out of lead, and that's to block the excess radiation that comes off, right? So there are 3 types of radiation that unstable isotopes, like this one, can give off. One is called alpha, beta, and gamma. So these are the 3, right? We can show them as symbols like this, right? Or we can also show them in their written notation. So something that you should know is an alpha particle, we also symbolize it as this. So notice that an alpha particle is basically a helium isotope with 2 protons and a mass of 4. So 2 protons and 2 neutrons. A beta particle looks like this, right? So this is basically an electron, right? This -1 means you're losing a proton whenever you're giving off a beta particle. And for a gamma particle, it's pure energy. And so we symbolized it by the Greek gamma symbol. You don't really lose any mass, you just lose energy. So this top number is 0, bottom number is 0. Right? So again, 3 types of radiation. These are the symbols to represent the radiation. And they all have specific names, right? So alpha particle, beta particle, and gamma particle.